All right, let's look at homework 2.5, 2.6, number 15. All right, so an object is thrown upward from the top of a 64-foot building. All right, so this tells you the initial position, which is h0. All right, and with initial velocity, so that's going to be v0 per second. Let the position function for a free falling object be, right? So it gives you that the negative 16t squared. So we just have to put those in. Let's put those in first, right? So it's going to be negative 16, so t squared. So that's given, right? Also v0 is 64, so plus 64. Sorry, V0 is at 48. Sorry, 48 T. Then initial position is 64. All right, so that's the position function. All right, then after that, velocity is simply the derivative. So I'm gonna go ahead and take the derivative. All right, so derivative of negative 16t squared would be, put t in front. So 2 times 16, negative 16 is negative 32. Right, t. Derivative of 48t is simply 48, and the derivative of 64 is 0. So that's that. Acceleration is the derivative of the velocity, so it's going to be just negative 32. All right, so those are the position, velocity, and the acceleration function. All right, so let's do part B. When will the object hit the ground? All right, so when object hits the ground, the height, the position is going to be 0. So we're going to have to set the position function equal to 0. All right, so let's do that. All right, so setting the position function equal to 0. So position function is up here. So first I'm going to actually factor out negative 16. Then you get t squared minus 4t. Oh, actually, sorry, that was 3. 3t, right, minus 4, right? Which can be factored out as negative 16 is there. T, so it's going to be quantity t and t. It's probably plus 1 and negative 4, right? Multiply 1 and negative 4 gives you negative 4. Add them up, you get negative 3, right? We set that equal to 0 since it hits the ground. All right, so this will give us t equals, right, negative 1, which shouldn't be the answer because we don't want to go back in time, and also 4 from here. All right, so when will object hit the ground? Looks like 4 seconds later. All right, so we're gonna put that in here. So that will be 4 seconds, right? All right, then when is the velocity of the object 0? Okay, so we can do that. We can just set the velocity equal to 0, right? So set the velocity equal to 0. But before that, maybe we should factor things out. So we can factor, looks like negative 16 out. Then you have 2t, right, from here. If 16 is out, so that's going to be negative 3, right? So we set that equal to 0. So which means that 2t minus 3 equal to 0, right? Then you can just add 3 to that. Then you get that 2t is equal to 3. Then we can just divide through by 2 to get that t is equal to 3 halves, right? So go back, and this is going to be 3 halves, right? 3 halves, right? The next one is, all right, how high does the object go? All right, so part C, we learned that after 3.5 seconds, the velocity is 0. So that would be the highest point, because that it goes up and it slows down and it stops. That's the highest point. All right, so we know that we can just plug 3 halves into the original equation. So let's do that. So S of, maybe I'll do it up here. So S of 3 halves, all right? Maybe I'll use this one. Looks like it's the simplest one. So it's a negative 16, right, times, if you type in, plug in 3 halves here. So 3 halves plus 1, so it's going to be 5 halves, right? And multiply by, all right? So 3 halves minus 4, all right? 4 is 8 halves, so it's going to be negative 5 halves, all right? All right, so 16 on, so there's a negative sign here. Negative sign cancel out. All right, 16 and a 2 cancel out, so that's going to be 8. And 8 and 2 cancel out, then you have 4 left, right? So it looks like it's going to be 4 times 5, which is 20, times another 5. So that's 100. Right? So answer there is 100. So you have to go down 100. All right. Then we want to sketch the graph using Geogebra. So let's open up Geogebra. Okay, let's type in position function, which is y equals negative 16. Instead of t, I'm going to use x, x squared, all right, plus 48x plus 64, all right, hit enter. So we got a graph, and the derivative is, velocity is y equals negative 32 x plus 48, right? Hit enter. And acceleration is negative 32. Hit enter. All right. Then I'm gonna just zoom out a bit, and so that we can see the whole thing. All right. Oops, sorry. Let's see. Zoom out. Right. And let's see. Maybe I'll stretch it out. Right. And here, bring it. All right. Now we can see. All right. So you can see that here is the position function. Here's the velocity function, right? Then here is the acceleration function, right? So let's find the correct graph. So that will be, looks like, right? So this is not it. This one is pretty close, but this is not the right graph. Right, so it seems like this is the correct graph. Let's double check, And going back to GeoGebra. All right, looks like this is the graph we're having. All right, so go back. All right, this would be the correct one. All right. All right, describe the relationship among these functions. All right, so let's look at that. All right, position function is it's a quadratic function, and velocity function is a linear function, and acceleration function is a constant function. All right, let's check the answer. All right, it came back. Looks like we got, let's see, we got those functions correct. And we got, let's see, everything, and let's see, we got the right graph, and yep, everything's correct. All right, that's it. I hope that this was clear.